Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal Hakim Ibn Ibrahim. My matrix number A20A1455. Here we will present about the relationship between insured age, sex, and number of children influence in taking life insurance. For the data description, the data set given was about a life insurance charger with 1,339 observations which contain a few variables like age, sex, and children. Table 1 shows a list of variables in two categories under quantitative and qualitative. Age and children are included in quantitative data while sex is included in quantitative data. For scale of measurement, age and children are in ordinal scale, sex are in nominal scale. The variable of interest are within sample in 350 observation over 1,339 observation and 28 as a sample size which can derive from the perspective of different field. Next is sampling data and record categorical data. We have used SPSS to random sampling the variable to get 350 observation from 378 observation based on our group matrix number. To group the age data, we calculate number of classes and class width. Formula to get the number of classes is log 350 divided with log 2, we get the 9 number of classes. To get the class width, we calculate max entry minus min entry divided to number of classes. We get 5 class width. So here is the table of insured age which has 350 frequency after making random sampling in SPSS. For insured sex, male was classified as 1 and female was classified as 2. The frequency of male is 176 and female is 174. Next is number of children. Here we have 0 until 5 number of children. The frequency of 0 number of children is 156, while 1 children is 78, 2 children is 63, 3 children is 44, 4 children is 6, and 5 children is 3. We can see that 0 number of children was the highest to take life insurance.
Hi, my name is Khairul Nasr binti Muhammad Tahir. I would like to present about the topic number 3 is numerical description measure. There are 3 measures that we need to find out, which are measure of central tendency, measure of position, and measure of variation. For the first one, to find out the measure of central tendency, we need to calculate the mean, mode, and median for insured age, insured gender, and also insured children. For calculation of insured age, since we already obtained the data given for insured age in the form of class interval, so we will use the formula from group data. Okay, to calculate mean, we use this formula as we can see here. X is a midpoint of a class, F is represent the frequency of a class, and then N is a numbers of entry in the sample. We just need to substitute the data from the table above to find the answer, and we will get the answer is 39.4. And then to calculate the median, we will be using this formula. We have a lower class boundary of median class, frequency of the median class, and then we have cumulative frequency before median class. After that, we times with the C, which is a class size or class width, and then the answer we will get 38.31. We can determine the answer by substitute the data acquired from the table. To calculate mode, we will use the formula. As we can see, LM is the lower class boundary of the model class, and then we have to sum bracket. In the bracket, this symbol we call it as a delta 1, delta 2. Okay, delta 1 is the difference between frequency of model class and the frequency of the class before model class, and then the second one is the difference between frequency of model class and the frequency of the class after model class. We have a C, which is class size and class width, and then we get the answer by substitute data and to the formula. So we will get 20.94. Okay, for insured gender, we will use this formula from ungrouped data, which is we can see here summation X over N. We get 524 over 350, and then the answer is 1.50 is a mean for insured gender. To find the median and the mode, we need to rearrange the data set by listing 1 for male and 2 for female. As we can see here, this table, from the ordered data, there are 350 entries, which is even number, the median will be the average of two middle number which are 1 and 1. So the median of insured gender is 1, which is a male. And then for the mode, from the ordered data, 1 appears 176 times, where 2 only 174 times. So the mode of insured gender is 1, which is a male. Next, we will move to the calculation of insured children. We use the formula from ungrouped data again. To calculate mean, we use the formula as well, and then we get the 1.07 is a mean for number of children. And then to find the median and mode, we need to rearrange the data set from ordered data. Okay, and from the ordered data, there are 350 entries, which is even number. So the median will be the average of two middle number, which are 1 and 1. So the median number of children is 1. Okay, and for the mode, since the mode is the greatest frequency, so we get mode is equal to 0. Okay, because from the ordered data, 0 appears 156 times number of children. To find out the major opposition, we need to calculate the first quartile and the third quartile for insured age, insured sex, and also insured children. We can calculate the first quartile and the third quartile by using the formula from group data. Firstly, we need to find the location of Q1 first quartile and the Q3 third quartile by using this formula. N over 4 equal to 350 over 4, and then we get the class interval is 23 and 27. For the Q3, we get at class interval 53 and 57. And then we substitute the value obtained from the table into this formula to find Q1, to find the value of first quartile. So we just have to substitute all over. At the end, we get the first quartile is 26.25, third quartile is 52.917. For calculation of insured gender and number of children, we also use the same formula to find the location and then to find the value. For example, insured gender first quartile is 1 and third quartile is 2. Meanwhile, the insured children, Q1 is 0 and then Q3 is 2. Now we will find out the measure of variation, which is we need to calculate the range, the variance, and standard deviation for insured age, insured gender, and also insured children. We use formula from group data for calculation of insured age. The first one, to find the range, we minus the maximum data entry and the minimum data entry. As we can see here, 65 minus with the 20, and then we get the answer of the range is 45. After that, we find the variance. We use this formula as you can see here. Just substitute the formula with the data given, and then the final answer is 210.24. For the standard deviation, the formula is similar with the variance except for the square root. Okay, after we get the answer for variance, we just have to square root the answer to get the standard deviation. So the final answer is for 14.50. Same goes to the calculation of insured gender. We just have to, we still use the same formula, and then for the variance, we calculate the variance. After that, we just have to square root the answer of the variance to get the standard deviation. As you can see here, the range for insured gender is 1, and then the variance is 0.251. After that, standard deviation is equal to 0.501. For calculation of insured children, range equal to maximum data entry minus with the minimum data entry, and then we get the answer is 5. For the variance, the formula is still the same. Okay, just substitute the formula with the data given, and then we will get the answer 1.419. After we get the answer of the variance, we square root the answer, and then we will get the answer of standard deviation, which is here. As you can see, the standard deviation is equal to 1.191.
Next, I will present about the graphical representation. For the insured age is quantitative variable data, so we have create a histogram and frequency polygon to represent the frequency distribution of the dataset. Based on the graph, it represents the midpoint of age at x-axis and frequency at y-axis. If we look at the graph, the highest frequency of insured age is 62 at the midpoint of age 20, while the lowest frequency of insured age is 15 at the midpoint of age at 65. The highest frequency at midpoint age 20 show that young people are aware of the importance of their life insurance. Next is graph of insured gender. Gender is qualitative variable data, so we have created a bar chart and pie chart to show the component of the unit of category. The pie chart shows the insured gender distribution in a study with 350 observations. The graph shows that 176 males, which is 50.29%, were insured, while 174 females, which is 49.71%, were insured. It also same as bar chart show the higher insured gender are male, which is 176, and female only 174. From the graphical data, it is clearly visible that male are leading the chart over the female in taking of life insurance. Last is graph of children. Children is quantitative variable data, so we have created a histogram and OGIF to represent the frequency distribution of the dataset. Based on the graph, it shows the total frequency number of children is 0 until 5. In the graph, it represents the number of children at x-axis and frequency at y-axis. The highest frequency of number of children is 156, which 0 number of children, while the lowest frequency number of children is 3, which is 5 number of children. This shows that unmarried people and families no children have more investment to take out life insurance compared to families with many children who need to spend more money to pay for families' commitment and subsistence that to take out life insurance.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Nursha Mimi Aziani binti Mama Azwan. My metric number A20B22X. So today I will present about statistical analysis using software which is SPSS. First of all, we go through in the part of age. We will look for measure of central tendency, measure of position, and measure of variation. As we can see from the table in the slideshow, it's different except in mean. Basically, it also known as a measure of location, and the main purpose to give an idea of what typical or common value for given variable. Let's see the evidence. We got the same result analysis output, which is 39.40, while the result for median and mode was different. From the manual calculation for median, we got answer 38.31, and in SPSS, the result show 14. For mode, we got to 20.94, compared to SPSS, the result show 20. It happened because SPSS act as an analysis the output directly, compared to manual calculation is usually using a formula. That's why the results are different. We move to the measure of position in term at age. The result between SPSS and manual calculation is different. Should be fine because the difference show the minor result in the first quartile and third quartile. The manual calculation for first quartile and third quartile are 26.5 and 52.917 respectively, while for SPSS the result for first and third quartile is 25 and 55 respectively. It explains that using software calculation is more accurate because the software calculation is more careful rather than manual may happen any mistake. Without further ado, measure of variation of the result show the same figure, which is 210.241. Next, move for the next slide, which is gender. The result use SPSS. We got the same answer, which is mean, mode, and median. Same goes for measure of position and measures of variation. Both of the type of measure give the same answer. After that, the number of children is measure of central tendency is same answer, which is mean 1.07, median 1, and mode we got 0 answer. The result of measure of position and variation also show the same result. We can conclude there are a few factors affect the result in SPSS, such as the sample data too large and it causes SPSS software calculate the data careful. Besides that, the student transfer the figure into the formula correctly. Let's move to the graph distribution using software. We already know the age is in quantitative variable data, so we choose to use histogram and frequency polygon to represent the frequency for distribution of data set. It was a good practice to know the distribution of our data before analyzing them. Second is gender. It is qualitative variable data. Based on the slide, the bar chart and pie chart clearly show the component of a unit of category. And lastly, for children, we use histogram and OGIF to represent the frequency distribution of dataset. Based on my reading, about 85% of the research scholars carry quantitative data for the further analysis. So the lab may think the SPSS is more beneficial in quantitative than qualitative. So we can conclude SPSS is used to predict trend and develop forecasts quickly and easily without being expert statisticians.
My name is Aina Ahmad and my metric number is A20A1248. So now I will proceed with hypothesis testing, starting with the t-test. So as you can see, this is the first variable, which is age, and here we have 5 steps. So for the first step is about the hypothesis. We state that H null is mu1 minus mu2 equal to 0, and for the HA, mu1 minus mu2 is greater than 0. For the second step is about the significant level, which is 0.05, and the third step is about the table. Let's focus to the first row, and the t-value, we got the t-value negative 1.776. So from that, we decide in step 4, reject H null if t-value is greater than TA, or the critical region that we got is 1.94. So in step 5, we can conclude that the t-value is lower than the critical region. So we fail to reject H null. Thus, we can conclude that the two population means are equal, or there is no significant difference between the two population means. And then for the second variables, we also use the same hypothesis and the same significant level. Okay. So this is now for the table. Let's focus to the second row, and for the t value we got 0.230. Okay. So we state that in step 4, we use the same critical region, which is 1.94, and in step 5, we conclude that we fail to reject H null because the value of the t value is lower than 1.94. Now let's proceed with ANOVA analysis, starting with the variable of age. So here we have 5 steps as well as the t-test, starting with the hypothesis. As you can see, for the H null, we state that there is no difference between the means and the other means, and for the HA, at least one of the means is different from the others. And the second step is about the significant level, which is 0.05. And the third step, we construct the table. Let's focus to the F value, which is 1.229. And then we proceed with the step 4. We said that we have to reject H null if F value is greater than FA V1 and V2. So the value of FA V1 and V2 is 2.240, and we compare it. We found that 1.229 is lower than 2.240. So we conclude that in step 5, we fail to reject the H null, and there is a significant difference among the group, which is 0.295. And then about the number of children, same method. We have 5 steps here, and we use the same hypothesis and the same significant level. And then this is the table, and we should focus to the F value, which is 8.827, and we compare it with the FAV1 and V2. For the FAV1 and V2 value, we got 2.398, and we found that 8.827 is greater than 2.398. So we can conclude that we reject H null, and the significant difference is lower than 0.01. Now let's proceed with the correlation analysis. As you can see, this is the table of correlation analysis, which have 3 variables here, which is age group, number of children, and insert gender. Okay, so the independent variable is insert gender, and the dependent variable is age and number of children. So the correlation between the insert gender and age group, as well as the insert gender and number of children, is weak, since the value of them less than 0.5. However, the direction of the relation is negatively. That's all for me.
Hello, my name is Muhammad Shafiq bin Shajarupi, and my metric number is A20A1488, and I will present about prediction modeling and the conclusion. For the prediction modeling is for proposing a reasonable model for the data. The objective is to test the relationship between the age, gender, sex, and the children. From the correlation table, the correlation between the age group and the number of children is negative 0.031, which is negatively correlated, and the strength of correlation is low. And the correlation between age group and the insert gender is 0.095, which is positively correlated, and the test shows a significant relationship between these two variables, while the strength of correlation is low. And the correlation between number of children and insert gender is negative 0.012, which is negatively correlated. And also, the strength of correlated is a low. The test of normality. From the table, we can conclude that the error are not normal distributed since the p-value are lower than 0.05. And the model of summary, from the model summary table, the R-square value is 0.001. This is mean that 0.1% of the age group can be explained by the two independent variables of ensured gender and the number of children. For ANOVA table, the p-value of the ANOVA test is more than 0.05, so we can conclude that at least one of the coefficients of the regression model is 0. And the coefficients. From the table, the p-value 0.860 of ensured gender is lower than 0.05, which indicate that the ensured gender is significant. However, the age group is significant as well to the model since its p-value 0.574 is more than 0.05. Since VIF for both independent variables are less than 10, so no serious multicollinearity occur. Next, for the conclusion. We can conclude that we have described the general information of the data and explained the variable of interest and the different categories of fields. We use histogram and frequency polygon for ensured age, pie chart and the bar chart for the sex, histogram and octave for children to represent the data and made an explanation through the graph. Hypothesis testing, which include t-test analysis and ANOVA analysis. In this section, we fail to reject H0 because of the two population mean are equal or there is non-significant difference between the two population mean, while in ANOVA analysis, we also fail to reject the H0 because of significant difference is lower than 0.001. The correlation analysis show the positively and negatively correlated result and the range of correlation between variables are low. Furthermore, the confidence interval result, the confidence range is similarly for each variable. The last part of this report is a theoretical modeling, which included the correlation, test of normality, model summary, ANOVA, and the coefficients.